Alright, this is the glider project, and I'm just going to show you just kind of the parts and what you need to put one of these together. As you can see, I just used the hot glue gun in different places that could be a little bit better cleaned up. This is a milkshake straw. I just have craft sticks. I have a 35mm camera canister, and I don't have the rubber band piece and the propeller. That part, it ends up, I'll just show you in a second, but once you buy these propellers, those 66-inch propellers from KELVIN Educational, this fits nice and snugly on the craft stick. So I have my film canister glued on here, straw glued on here, and then all you do is you connect the rubber band to this metal piece right here, and you just pull it back, and then you begin to do your turns. And so essentially this is the project. And so the parts that you need to make this, kind of just put it down here, it's kind of an easy frame of reference. So you'll need hot glue gun, glue, you'll need fishing line or a type of wire, you will need drinking straw, and with this one I just cut it a little bit. I cut that part that has the perforations, so that part that bends I removed. Optional smiley face, again the drinking straw, the craft sticks, this is the propeller, and you get these at KELVIN Educational. They're 6-inch propellers. The film canisters, you can get these at camera shops. Need to recycle these, so they want to get rid of these 35mm film canisters and rubber bands. And so this is essentially what you need to make this. And so you'll use hot glue to put it together, arrange that along the sides, and then this one has 4 because it has a bigger straw in it. Again, you can play around and vary the sizes of the straws. Alright, so now we're talking about just some ideas as you go about the project, and we're essentially looking at Newton's second law. We're looking at changes in an object's motion, and we're looking at forces acting on our object, and we're looking at the sum of all forces and how that affects our object. You want to begin to tie in gravitational force, force due to tension in the wire, frictional force, both static and kinetic, also air resistance, and also thrust from the propeller. So those are some ideas when you begin to talk about the sum of all forces and the forces that are going to be acting on your object. The evidence that you would like to gather, again, the sum of all forces, the mass of the object. So as I vary the mass, what's happening to the acceleration, increasing the mass should have a lower acceleration, decreasing the mass should have a higher acceleration. Number of twists in the rubber band, again, this should follow proportionally. You should have a higher acceleration with more twists, and that idea there. And if you have access to tracker, I've put a link in there for that, so you can have you could also have students use meter sticks and stopwatches too. So you'll want to gather some position data as well, and so this is some of the evidence you want to gather with changes in motion. You might want to begin and just have the glider just resting on the wire itself and begin to talk about Newton's first law: an object at rest will remain at rest until acted on by a non-zero net force. And so this idea of the tension and gravitational forces, the sum of all forces, they're zero, but they're acting on the object. Just an idea that you need to make sure to go through with this. Again, as we begin to twist, make twists in the rubber, and you can talk about cross-linking in rubber and the relaxed state and the stretch state of rubber. You can begin to talk about polymers if you wanted to go back to the rubber band and sort of the material aspects of it as well. And again, as you begin to twist and turn the propeller, as it begins, it may turn, and the object, the glider, may remain in place, and you can begin to talk about how discussions, as it's just starting, with static friction. And so you can begin to say, okay, the propeller pushes on the air pushes on the propeller. This idea of Newton's third law, well, it appears that the object is just still in a static condition. It is resisting motion, and so this idea of static friction you can bring up. And lastly, you can talk about the varying, whether it's speeding up or slowing down, the variations with acceleration as you have differences in thrust. So the sum of all forces, once it's added up in this rightward direction, as it's accelerating in this direction, you can begin to talk about, again, air on the object, why do objects move, bringing Newton's third law into play, and also begin to talk about, as I vary the mass in the canister, as I vary twists in the rubber band, those topics there. So again, evidence you'll want to gather during the experiment, forces acting on your glider, and then these are just some teaching approaches. There's just some ideas of what to include in MS-PS2-2, HS-PS1-2